Alright, on this day we talked about zeros of different multiplicities or factors of different multiplicities and how that shows up graphically. And we can describe these in a couple ways. One way that we see on the problem set is using a table. So we can split up a function into intervals based on where its x-intercepts occur. So in this case, in the first function here, we have an x-intercept at x equals -3, and actually both of them have the same intercepts by design. So they have intercept at x equals -3, x equals 4, and x equals 6. So when we make these intervals, okay, well, we're going to go from -infinity until we hit -3. That's what's happening here. At -3 we have an x-intercept, so we say -infinity until -3. Okay, our next interval is going to be -3 until 4. And then our next interval is 4 until 6. And then we're going to go from 6 to infinity. Alright, so a couple things to notice here. We should notice the degree of the function. It's a degree 2, 3, 4. It's degree 4, so it has end behavior up, up. So if the end behavior is up, up, that means the output has to start positive, because the end behavior with the arrow pointing up means the outputs are going to be positive anywhere between -infinity and -3. Now, what happens at -3? At -3, the output is 0, right? So then what happens? Well, the x plus 3 squared sign is always going to be positive. So the only one that's changing signs out of these three is this factor, right? But it's not changing signs because it's squaring. So that tells us that the function must bounce and stay positive. Okay. Then what happens at x equals 4? Well, it's 0 again, and after x equals 4, this factor is going to change signs. And since this changes signs, the whole output is going to change signs. So we go from positive to negative. And then what happens at 6? It's 0 again, right? And because it's x minus 6 to the 1, this is going to change signs now. So think about it. If we plug in 5, we have 5 minus 6, which is -1. So this output is negative. The factor is negative. But if we plug in 7, we get 7 minus 6 is +1. So what we're saying is, at x equals 6, this factor is changing signs, which changes the whole output. So it switches back to positive. So it's positive, it hits 0, it bounces, it stays positive, it hits 0, it crosses over to the negative, it hits 6, it's 0 again, and then it crosses back over to the positive. So we'll sketch these in a second and look at the differences. I'm not going to rewrite these intervals. This function has the same intervals, but we'll talk about how it behaves differently. So this one is a degree 1, 2, 5, total degree 5. So that means its end behavior is down, up, so it must start negative. Okay, what happens at x equals 3? Or sorry, -3, it crosses because that's multiplicity 1, so it switches positive. Okay, what happens at x equals 4? It crosses again, back over to negative. And then what happens at x equals 6? It crosses back over to go positive. Okay, so we have an end behavior of down, up, which is what we would expect with the degree. So sketching now by reading our tables that we've come up with. Oh, that was a terrible box. Here we go. Alright, so we start positive. We hit -3. It bounces and stays positive. Okay, it's going to come through the y-axis. It's going to cross at x equals 4 and then cross back at x equals 6. And we'll just pretend that I actually was able to go through that when I drew this. Okay, so then if we look at the other one, okay, this one starts negative. It's going to cross through at x equals 4. It's going to cross back through, or sorry, at -3. It's going to cross back through at x equals 4. And then what happens at x equals 6? It shoulders. Okay, so we should talk about why it's shouldering. So if we go back and look at the function, it's x minus 6 cubed, right? So this kind of takes on a cubic shape when you hit the x-intercept that happens at this factor. One thing we talked about in class is what happens when, so if you plug in a number close to 6 here, if you plug in numbers between 5 and 7, you're going to take a number that's smaller than 1 and we're going to cube it. And we talked about how cubing a number smaller than 1 is going to produce a smaller output. And then if we take it to the 5th, it produces an even smaller output. If we take it to the 7th, it produces an even smaller output, which is going to cause flatter and flatter shoulders. So that's the last thing we talked about. But anyway, because this is x minus 6 cubed, it doesn't just cross straight through, it has to shoulder through. So here we can look at this again. So here we have x equals 5. That's the line I've marked. That's where the 0 happens. So if we plug in numbers between 4 and 6, right, then we're taking a number smaller than 1 and taking it to the 5th power. You can try this in your calculator. Do like 0.5 to the 5th power, then do 0.5 to the 7th power. 0.5 to the 7th power ends up being smaller. So when we're between 4 and 6, we hug that x-axis for a little bit longer because those outputs are smaller compared to this one. Okay, x minus 5 to the 8, that bounces, but it's a flatter bounce. Again, because between 4 and 6, if you take a number to the 8th power, it's going to produce a really small output. And the higher this exponent is, the smaller those outputs are. So the flatter it ends up being, either a flatter bounce or a flatter shoulder. I'm just going to do one more example. So if you're feeling good, you can feel free to turn off the video, but let's just look at one more. So here we have our next example. I've already made my intervals based on where the x-intercepts happen, right? So you want to be able to fill in this top part by yourself, but it splits up the function into sections based on where it hits the x-axis. We see this is degree 3, 5, 6 total, so it should have in behavior up. So we can actually already just fill in the first and last box. Those should both be positive, right? What happens at -1? So be careful here. This is the -1, 0. It bounces. So it goes positive, 0, stays positive. Okay, at +1, it shoulders, so it goes positive to negative, and then at x equals 3, it just crosses straight through, so it goes positive. So if we were to sketch this, okay, here's our 0 at -1, here's our 0 at 1, and then we have our 0 at x equals 3. Okay, we should be careful and label those normally, but here we go. So we're starting positive, we're bouncing at -1. Going through the y-axis, we then cross through, and then, wait, did I mess that up? It's supposed to shoulder there, right? Yeah, okay, cool. Let's try that again. So it bounces, it shoulders through, and then it crosses, right? And then again, if this were x minus 3 to the 5th power instead of cubed, you would want that shoulder to be flatter. If this were x plus 1 squared, or to the 4th instead of squared, you want this bounce to be flatter. All right, that's it. So the only other thing that I want to say is make sure that you need to be able to look at a table and think about what the graph might look like. You need to be able to look at a graph and think about what the table might look like. Or sorry, yeah, graph and think about what the table might look like, and also look at the function and know what the table and the graph might look like. So you want to be able to interchange between all three.